Let's do some guided practice with the formal definition of the derivative. Remember, we're always using the limit definition of the derivative. So we've always got the limit as h approaches 0 of f of, in this case, negative 1 plus h minus f of negative 1. And that's just going to be 2 times negative 1 squared minus 4 times negative 1 plus 1. This is all divided by h. Now, and this takes a little bit of simplification, but all you're doing is you're just foiling. All right, this will become 2 plus negative 1 squared is 1. This will actually be minus 2h plus h squared. And then we have plus 4 minus 4h plus 1. And then this is going to be minus, I'll do this in parentheses, 2 plus 4 plus 1. Okay? And notice the 1's cancel, the 4's cancel, and the 2's cancel. Right? And this is all over h. And so when we simplify this a little bit, don't forget about that 2 out front. We're going to have negative 4h plus 2h squared minus 4h. Oh yeah, I guess that's what we have. And then it's all over h. And then we can just simplify this to be the limit as h approaches 0. We see that we're going to get a 0 over 0 limit here. So we just divide up by an h, and we get negative 4 plus 2h minus 4 all over 1. And we're going to get an answer of negative 8. All right? Just doing a quick little check. Yeah, right. Just doing a quick little check. Let's see if we get 4 times negative 1 minus 4 times negative 1. Yep, we get negative 8. Yep, that is correct. So, by the way, I just sort of quickly verified by looking at the function. So maybe there's a shortcut, but maybe we'll look at that later. Anyway, on to the next one. F prime of 5 equals, limit as h approaches 0 of f of 5 plus h minus 1 minus f of 5. Okay, yeah, I'm just going to simplify this to 3, right? It's 2 times 5 minus 1, 9. Take the square root, we get 3. All over h, right? Now, how do we solve it at this point? Well, we know we're going to get 0, 0. So we just multiply by the conjugate, right? So we're going to get 2 times 5 plus h minus 1 plus 3 over, itself. So when we do this out, we get limit as h approaches 0 of 2 times 5 plus h minus 1 minus 9 all over, and again, this is going to be a mess of a mess, but that's okay. 2 times 5 plus h. And so when we clean all this stuff up, note that the 2 times 5 minus 1 is going to cancel with the 9. Right, so we get left with limit as h approaches 0 of 2h over h times all this nonsense. What is going to be 2 times 5 plus h minus 1 plus 3. And then we just cancel those h's. Note that we're always dividing out by that 0 on the bottom. Okay? And we just plug stuff in. We get 2 over, what is this? The square root of 2 times 5 plus 0 minus 1 plus 3. And that winds up being 2 over 3 plus 3, which is 1/3. Right? And that's our answer, 1/3. There, okay. And last but not least, right, we have f prime of 3 is going to equal limit as h approaches 0 of 1 over 3 plus h minus 2 minus 1 over 3 all over h. Now remember, this looks kind of yucky, so we're going to simplify it. And remember, one of the ways that we simplify this, put the 1 over h out in front. Also, let me go ahead and move this over here just in case, okay? And then this is going to be 1 over, and it's actually 1 plus h. Do you see that? Oh, shoot. Sorry, this is 1 over 3 minus 2. Forget about that. 1 over 1 plus h minus 1. Okay? So what we're going to do is we're going to multiply this by 1 plus h over 1 plus h. Okay? And this winds up giving us limit as h approaches 0, 1 over h times 1 minus the quantity 1 plus h all over 1 plus h. Now just be careful. Make sure to distribute the negative sign to both the 1 and the h. Okay? And anyway, we get the limit as h approaches 0 of 1 over h times, and that's going to look, the 1's, of course, cancel as they always should, and we get negative h over 1 plus h. Well, that's going to cancel with that, and we're left with a negative 1. Well, just to be clear, that's a negative 1 right there. Don't forget about the negative. So we have negative 1 over, well, 1 plus 0. Negative 1. And that's our answer.